Okay, so page 13. Let me point out what you can expect for the test, and also it'll line up with what you see up there on the board. There are some problems that are going to be just power rule, like this one. If you look at number 1 here, there's no need for U substitution because the radical doesn't have multiple terms in it. There's only one term in the denominator. There's no messy expansion that we couldn't get out of. Okay. And even a problem like this, you guys tell that this is power rule and not U substitution. I know there's some messiness to this, but ultimately still just one term. And this is perfectly expandable, right? It's not like it's a square root of x plus 1. This is expansion, even though we do see a set of parentheses, it looks complicated, but this we can do using just power rule. Okay. Meanwhile, a problem like this, you got to go through substitution. There's too many terms in the denominator, or even the radical in the numerator with multiple terms in it. Anytime your radical with multiple terms in it, or your degree, let's say degree was too high, this is raised to the 3rd or 4th power, then you can look at U substitution. Okay, but something that is manageable like this, or number 1, we need to be able to see the problem and recognize that as power rule expansion, and there's no need for U substitution. Okay. Problem like number 2, there's a combination of U substitution problems, maybe one that involves trig. So we'll go through one like that. We're going to see depth integral problem, where you're going to ignore the bounds. You're going to evaluate the antiderivative and then plug in lower bounds. Sometimes there's a problem here where it's a U substitution, but it doesn't, the x's don't cancel out. So you got to go through another round of substitution called change of variable. Change of variable, I have that as option as bullet point number 2. Okay. Back page. Problems involving second theorem. Right, we practiced through that to be able to recognize the need for second theorem. Derivative integrals will cancel each other out. We did this yesterday, but absolute value function, right? Know how to sketch the graph out. Once you sketch the graph out, then you're just adding the areas of 2 triangles, and that's going to be your integral. We'll go to number 11. This is similar to what you saw in the quiz, going from the second derivative to first derivative to f of x. And then along the way, once you find the antiderivative using power rule, you're going to solve for c along the way. But instead of calling it f prime, and f double prime, I'm going to call this position, velocity, acceleration. But it's the same process, right? Antiderivative twice. And then number 12, it says find the average value. So this is average value theorem, but we're going to add up the areas that we see here. So you'll see a problem like this on the test. Huh? Yeah, up on the board there are 7:15. I'll send a reminder this afternoon. Yeah.
You record the help sessions? Like, are they on the YouTube?
Yes, I will record and I will send out the Teams link tomorrow morning as well. Okay. But I recorded the morning help session from last year. So if you want to watch tonight from last year, you can click on that. I'll have it under tomorrow's date or today's date. Oh, you'll also see a trig problem where there are bounds involved, and there's bounds involved, then we gotta evaluate and involve unit circle values, right? So we'll practice that as well. But oh, sorry, one thing I left off that is not on this review sheet is what we did yesterday on page 2. I think we practiced with that enough already where, or sorry, page 1, where it's not on this test review, but it's an even odd function. But I think hopefully we did enough of those where you feel pretty comfortable with that process. So that's the only thing that is not on the review sheet that will be on the test. There's even odd functions. Yeah. So it's not on page 9 and 10, but you'll see that on the test. Sorry, not on page 13, 14, but you'll see that on the test.
Okay, let me actually start on page 14 and work backwards because I feel like maybe we've done enough of the use substitution where hopefully we feel at least we've seen it enough times where we can self-manage ourselves. If we don't get to it, you can practice that on your own with the key that's attached. But let's start on page 14 and run through some of these problems. So page 14 here. Do we need to do another second theorem? Do you guys feel okay with that? Okay. You guys can manage that on your own. Okay, if you know the rules, you can apply that. Why don't we do another absolute value function? You'll see one like this. I know we did one yesterday, but we did number 9. So can we try number 10? So see if you can sketch out what that triangles will look like. So we did number 9. Now let's try number 10. Okay. Again, if you want to find the height at the corner here, that y value will also tell us the height of the triangle. So if I plug -2 in for x, -2 minus 4 is -6. Absolute value -6 is 6. This order pair is -2, 6. And so that also represents the height of my left triangle. 7. If I plug 7 into the function, I can get that location, and that location, y value, will also tell me the height of that triangle. 7 minus 4 is 3. Absolute value of 3 is still 3.
It's gonna be the same numbers.
Yes, because I will give you one where the slope is 1. That slope, y equals x minus 4, that's really the slope of 1. Yeah. But down the line, if this was a different slope, then I think the safest thing to do is always plug that x value into the function and convince yourself that's the y value and that's the height. Okay, so now what do you do? Find the what of these two triangles? Area. Area formula is
Base times height.
1/2 base times height.
How'd you find the height again?
Okay, how do I find the height? So I know that if I can find the location of this point, then that y value will be the height of that triangle, right? Does that make sense? The y value here will represent the height of, will be the highest point of this shape, and that is the height of the triangle. How do I value, right? So this is my function, right? So if I plug -2 into the function, I can get the y value. So -2 minus 4 is -6. Absolute value -6 is 6. Okay. Okay, 1/2 base times height, 1/2 base times height. Then 1/2 base times height. Okay, so 36 over 2 plus 9 over 2. All right, any questions with these? If we see this, we feel comfortable with that process?
Find the area of line of both triangles.
Right, that's right, of both triangles. Of the full region between the graph and the x-axis. That's what every integral problem is doing. We couldn't do this with other problems because other problems have curves in it and the curves are not nice geometric shape. But these are nice diagonal lines that will always create these geometric triangles for us.
Your bounds are your x coordinates.
Your bounds are x coordinates, that's right.
Would always be the case.
Mhm. Okay, are we good with these? All right, let's look at 11. You'll see a problem like this where you have to get from acceleration to velocity to position, but you're doing the exact same thing that you did on the quiz. And it says find a specific function for velocity. Well, let's set it up here. I have acceleration to begin with, so we know velocity is simply the antiderivative of acceleration. Okay. Everything is nicely set up for power rule. Four becomes what? Plus C. Okay, how can I solve for C? Okay, -1 for T, yeah, and then 9 is my velocity. Okay, what's my C value? 0. So it looks like I'm not going to have a constant. I can just, well, I can just take this and just drop the C, right? Hey, we're halfway there. Now we can take that antiderivative once more, and that will take us to the position function. So I'm going to set up what I want to do. I want to take the integral. Go through the power rule again. Plus what? Yeah, C2 or plus K. Clean this up. Okay. Do you have something available to help us get that C sub 2? Can we use? Yeah, 1 plugs in for,
T.
yeah, and 3 goes in for the position.
You solve for the C values, try to get that value.
Yeah.
So specific function, that means you solve for C.
Yeah, that means solving for C, replacing C with a number, and then rewriting the function with the C's replaced, right? Okay, number 12. Number 12 says average value theorem. You guys remember what's the formula for average value theorem? F of C equals what?
1/b.
That's good. Integral from, yeah. The function is given by this curve, so we're actually just going to add the areas up. We're not going to do power rule here. So if the function was given to us, we'll go through a whole power rule process. But if the graph is given to us, we're just adding the area, right? They mean the same thing. They're just different application. And what are our A and B values? -2 and 5. So the 1/7 is the width component. This is the area component. And we're going to pull the area from the graph. So once you get the area component, don't forget about your width, because you're trying to find the average height. So basically, all these y values have different, all these graphs have different y values. Well, some of it staying the same, but if we were to average out all these different y values, what is the average height? That's what we're looking for the average height. Okay, let me highlight what graph we're looking at, because in this case, we're extending from one end to the other end, but if it doesn't extend all the way to the entirety of the graph, then we got to pay attention to our bounds, right? Our bounds is what we are always paying attention to. We can't assume that the entire graph is always going to be, we can't assume that we're looking for the area of the entire graph. Right? The bounds, always pay attention to the bounds. If it's only a portion of the graph, then you're only going to deal with a portion of the graph. I know this one does extend all the way, but that may not always be the case. Okay. All right, let me highlight the graph here. So we got the graph looking like this. And I'm going to shade in what's between the graph and the x-axis. That's the only part we care about. We don't care about anything that, if there are other shapes that you see, that's not part of our graph. We only look at what's between this graph and the x-axis. So if we total all this up, then that can represent the area. But we got to be careful. Anything that's below the x-axis, we got to represent that as what?
Yeah.
As a negative. So I'm going to go down and find the area of each. This is 1/2 base times height. This is base times height. this semicircle is 1/2 pi r squared. Okay. I'll give you the formula for circle if it shows up on the test, but you just, to get the semicircle, just divide it by 2. So 1/2 plus 1/2 plus 1/2 is 3/2. 3/2 plus 2 is 7/2. So this is my area component, but I'm not quite done yet, right? To find my average height, I still got to involve the what? Width, yeah. So I got to take that area, put it into the integral, and then multiply by 1/7.
Like the 1/2 plus 1 plus 2.
Sure. So this triangle is 1/2 base times height. So 1/2 1 times 1 will be 1/2. This square is length times width. So 1 times 1 is 1. Triangle here, 1/2 base times height. 1/2 1 times 1 is 1/2. This here, a semicircle, has a radius of 1. So 1/2 pi r squared. Pi radius is 1, so 1/2 pi times 1 squared is 1/2 pi. It's below the x-axis, so I want to make sure I include the negative minus 1/2 pi. Above the x-axis, 1/2 base times height, 1/2 1 times 1, which is 1/2. And a rectangle square is length times width. What if this integral, what if the bound was from -2 to 4? Then this would be 1/6. And would I then add up all the areas still? Only up to 4, right? Okay, so pay attention to your bounds. Okay, so are we good with second theorem? Absolute value. Particle motion in terms of taking the antiderivative. Average value theorem, even odd function. Second theorem?
Yeah.
Yep, okay, we'll do that. Okay, let's try number 7. It says find the derivative of this function. So I want to find the derivative of something that has an integral in it. So it's going to be something involving second theorem here.
What is that? SFTC thing.
Second fundamental theorem of calculus.
Okay.
Yeah. All right, so we know second theorem. We're going to just plug in our upper bound and evaluate it that way. So here's second theorem. So we know these two operations will cancel each other out. We're just going to plug the upper bound into the function, multiply by the upper bound's derivative. But what do you notice about number 7 that we also have to do? Say it again. Yeah. What else? Okay, how many times do we have to go through this process? Twice. Lower bound is also a variable. If this lower bound was a constant, we can ignore it and just have to do at the top. But because lower bound is also variable, we got to go through this process twice. So f of p of x, upper bound into the expression, multiplied by yeah, we got to find the derivative of that upper bound, right? That p prime. Minus, repeat the process for the lower bound. Times what's the lower bound's derivative?
Oh, the low.
Mhm.
I don't want to have X anymore.
So I rewrote this square root of x as x to the 1/2. And then I did power rule, right? What's the derivative of x to the 1/2? Negative 1/2.
Oh, we don't have to.
Yeah, you don't have to clean up. As long as you have all the pieces there, I'll accept it.
The AP exam you want for that.
Yeah, AP exam also will accept answer unsimplified. The only time you have to simplify it is if it's a multiple choice and you're trying to match your answer with the multiple choice option. Okay, what about number 8?
You only have to do.
Pick the solution.
Yeah, you're right. The only one bound is a variable, but we would like that variable to be where?
In the top.
The top. So we can flip it, but if we flip the order of the bounds, we got to do what? Yeah, put a negative in front. And once you do that, then you're just going to apply second theorem again, upper bound into the expression multiplied by upper bound's derivative. And you can ignore that pi. That pi is not going to be, it's going to just wash out. Question.
It's not necessary. That's.
You're right. You're right. You can just do 0 minus that lower bound and you'll get the same answer that way too. Yeah, you can do it that way. Okay, let's go back to page 13 and see if we can highlight a few problems here. Okay, let's look at number 1 again. Page 13. So we can tell by looking at this problem, there's no need for use substitution. This is expansion power rule. So split up into individual fractions, clean everything up, just like how we did on the quiz. Okay. Number 2, can I distribute my way through and rely on power rule? I cannot, right? So I got to think about use substitution. What could be our U value? Yep, once I get that radical to be in terms of a rational exponents. Okay, number 3, can I expand my way through this problem? Look again. Yeah. This we can. The square root is only over 1 term. That's not an issue. And also the second set of parentheses has no messy exponent outside, right? It's not raised to the 3rd power. It's not raised to the 1/2. We can distribute this through and rely on power rule, right? So this we can expand and rely on power rule. No use substitution needed. Okay. You see that distinction between number 2 and 3? I know they both have radical, they both have squared, but this we can't do, but this we can just do power rule. All right, I want to change up number 4 to make it a definite integral so that we can practice that process. So I'm gonna, maybe you can try number 4 later because there's a key attached. But I'm gonna call this 4b.
What number 4 is being explained?
Huh?
Number 4 is being explained.
This one we can't expand because there's secant involved. So we got to think in terms of u substitution. Our u value will be 3x squared.
Okay.
Because secant squared u turns into tangent. Let me change it from, sorry, let me go from 0 to 2 pi. Okay, so first things first, we ignore the bounds, right? We take care of the secant squared 2x. We don't have a, I mean, this looks like the rule that we want to use, secant squared, but what's our u value here? 2x. All right, let me change this again and make it pi over 6. Okay, yeah, so u equals 2x. We clean everything up to get it ready. Okay, where can I put that 2? Outside as 1/2. Okay, we're ready for our rule. What's the integral of secant squared? Okay, are we ready for the bounds? One more thing we got to do. X, yeah, because the bounds are in terms of x. Either you convert the bounds to x in terms of u, or you get everything in terms of x. So I have tangent of 2x. And now I can think about the bounds. Sorry, thank you. The 1/2 needs to stay, yeah. Okay, upper bound first, right? So 1/2. Okay, I know we plugged in the upper and lower bound, but this is not reduced enough. We got to get the trig out of the way. Now, if these are just numbers, you can leave numbers there if it was another definite integral problem. But with trig, we got to go further. We got to use unit circle values. So we think about tangent to pi over 3. Tangent is y over x. So tangent pi over 3 is what? Root 3 over 1, which is root 3. Okay. Gradient measure 0, that's over here. My order pair is 1, 0. What's tangent of 0? Y over x, right? Sine over cosine. 0 over 1, that's a real number. That's 0. Okay. Review your unit circle values. Okay, let's end with number 5. Okay, so number 5, we have to ask ourselves, can I distribute this x squared through and just rely on power rule? No. So we're stuck. U substitution has to be our next option. Get the parentheses to show up. What's our U value?
7 minus 8.
But there's a problem, right? The derivative is not going to be large enough to produce in something that will cancel this x squared. We're still going down the right path. We just have to do some additional work to undo or replace that x squared later down the road, right? We can't move forward unless all the x's have been converted or canceled out. What's our derivative? -1. Cross multiply. Dividing by -1 is the same thing as multiplying by -1. Okay, so the x squared is still getting in the way, right? We can't pull the x squared out. We can't do power rule. This is being multiplied. This is change of variable here. How can I get that x squared, or how can I get that x to disappear or to be rearranged? Solve for x here, right? What's x equal to? 7 minus u. Okay, once we make that substitution, there's still some work ahead of us, but at least we're going to have a pathway towards getting it ready for power rule. Okay, I'm gonna pull the u to the 1/2 and -1 in front. That way I don't have to think of those as I can kind of merge some things together. But we can't do power rule yet, right? We still have to undo the parentheses. So make sure you don't distribute first, that you FOIL first. Okay, almost there. Distribute that -u to the 1/2 through, and then the parentheses will be gone, and then we can do a power rule. Okay. Ready for power rule. Once we apply power rule, we can drop the notations there. Okay, pull the reciprocals, pull the denominators up as reciprocals. -49 times 2/3. Okay, are we done yet? We're near the end, but there's one more thing, right? Replace u with what? 7 minus x. Yeah. I encourage you guys to work through, for practice, the rest of the review packet. If you want to look through some of the problems that we didn't do, you can skip pages 5 through 8. These pages 5 through 8 will not be on the test, but we can revisit these next week when we get ready for the calculator portion. And then tomorrow morning, I'm going to go through pages 17 and 18 during the morning review. All right, come get your phones. Which number?
I got it.
Okay.
Homework,
Okay.
Monday.
Okay.
And,
Okay. Then do you want to take BC or
sorry. I was saying,
BC? Okay, I'll put you down for that. But you can always change your mind later.
okay,
all right.
perfect, thank you.